Hello everyone, good day to you all. Welcome to Train Firm's video on time series and forecasting, especially on ratio to moving average. This is Matthew Besant Thomas from Train Firm. We will discuss on ratio to moving average method used for forecasting today. I hope that you have watched my previous video on time series forecasting, especially on trend analysis. We did discuss about the fundamentals of time series and forecasting there. Those fundamentals are really required for you to understand ratio to moving average method for forecasting very well. So in case if you have not watched my previous video on time series and forecasting on trend analysis, I would recommend you to go and check out that video so that you will get a fair understanding of the basics of time series forecasting. And still, in case if you have any doubt, please do not hesitate to reach out to me. You can drop an email to me at info@trainfirm.com. And that will take care of you getting the basic doubts cleared. So I'll try and respond to your queries as quick as possible. Okay, with that, I'm going to begin with this session. Let's try and understand what is ratio to moving average. It's also known as classical decomposition, right? So when to use a ratio to moving average forecasting technique? This technique is used when there is a seasonality element or a seasonality pattern in your data series or in your time series data. And once you account for seasonality, then you have techniques to account for the cyclical and the trend component as well. So primarily, if there is a seasonality present in your time series data, we can go ahead and use the ratio to moving average forecasting technique, which will give you a genuine forecast number for future. Where to use it? What type of data should be there for us to use the ratio to moving average? So if your time series data is all about something which has a constant demand, a commodity or a good or a service, with slight fluctuation in seasonal patterns and trend patterns, right? The seasonal patterns may not be always constant. It could be having slight fluctuation, and then that is where I would recommend to use a ratio to moving average method. And the whole purpose or the objective of ratio to moving average classical decomposition is to decompose your time series into various components, including trend, cyclical component, seasonal component, and then the remaining is the irregular component. So once you decompose this 4 components, we can individually go ahead and create forecasts for these components which are regular in nature, right? So that means your seasonal component, if you can create a forecast, your cyclical component, if you can create a forecast, and your trend component, if you can create a forecast. A majority of your components will be regular components, and then you can make a very good forecast on that, and leaving aside only the irregular component, which you may not be able to generate a forecast for, and we will live with that error in our model. But if you account for majority of your regular components, provided your data is not a random walk, I think we will be able to generate good forecasts which are reliable and can be used for business decision making purposes. In this exercise and in this video, I will be talking about how to conduct this technique, how to do this technique using Excel, and of course we can discuss about how it is performed in Minitab as well. In my subsequent videos, you can expect one session on how to use the software R to get the moving average forecasting process done. Okay. In this video, we will restrict ourselves to Excel and Minitab. We will learn the fundamentals, we learn the basics of this, and we will also see by taking an example how that example can be worked out using an Excel or a Minitab. Okay. So I have covered the slide in my previous video, but just let me spend 1 minute on this just to refresh your memory. I did talk about decomposition as the name of this method, decomposition, classical decomposition. So once you decompose a time series, you will decompose that time series into 4 different components. One is a trend component, we denoted by T. Then the second one is the seasonality component, which is denoted by S. Then you have got the cyclical component denoted by C, and then finally the irregular component or the error component, which we generally denote by I. So these are the 4 basic components of a time series, right? And then you have got different types of decomposition models, which we have to select before we get start with our analysis. So the typical 2 types are additive models and multiplicative models. As you may remember in our previous video, I've given the explanation. Additive models are those models with a constant amplitude for the seasonal variation. That means this amplitude remains same over time. There is no major difference, there is no major change or variance in this amplitude. But whereas in a multiplicative model, we see that it's a multiplying effect where the amplitude changes through time. The amplitude of the seasonality here is different from the amplitude of the seasonality here, and that's typically the behavior of a multiplying model, a multiplicative model. Okay, so that's basic few things which you will need to keep in mind before we proceed with the analysis. Okay, so why the name ratio to moving average, right? Why do we need moving average? So moving average has to be calculated upfront in this method. And why do we need to calculate that moving average? So the word averaging itself, what are we trying to do, right? If you have got observations slightly with higher variation, right? Say, a variable having observations, say 5, 10, 20, 3, 40. So that means, there is a variation. So if you take an average of this, right, that average is going to nullify this variation, right? So that's a point average, right? And it's going to give you a simple single number. But when it comes to moving average, right, if you decide on the order of the moving average, it takes the average of, say, a certain number of values and create a point to represent those values, and then subsequently it goes move forward. So what happens when you take the average, a lot of variation in the original data set gets smoothed out, right? So when you smooth out certain variation in a time series, 2 things get eliminated from that. As you see that, this variation, first variation or the first fluctuation is due to the seasonality component, right? So when you take a moving average, say, let's take an example. If you see the screen now, there are around 4 values here. If I take an average value of these 5 values here, right? So if I take the average value of this 5, I represent this with 1 point. So a lot of variation has been smoothed out, and I've got this 1 point to represent this 5. So when I average it out, the seasonality and the irregular component, the random component, the swing in the data gets cancelled, right? And all I will have is just the trend component and the cyclical component, right? If you remember, there are 4 components, right? In a time series, I've got the seasonality, trend, cyclical, and irregular. So if I take the moving average from a total time series, I'm eliminating the SI component, right? The seasonal component, seasonal variation, and irregular variation, which leaves out the TC, that's the trend and cyclical variation alone. So in other words, Once I take moving average, MA, if I call it moving average, the result will become TC for me, right? It's just the trend component and the cyclical component. So far, so good. That now, once the point one is took the moving average, we have got TC component with me. And then from the original series, right, if I am dividing it with the moving average, right? Once I take the moving average, I told you we will be left with only TC component. If I divide my TCSI divided by TC, what happens? Both TCs will get cancelled, and then what is resulting is one component called as the SI component, which is the seasonal variation and irregular variation. So I will be left out with the SI component. I will be cancelling off the TC, trend and cyclical part of the original series, and then I will be left out only with the SI. So two things we have got in hand now. One is the TC component alone, a column with TC component alone, and another column with the SI component. Now the task is to just isolate the seasonality from this component. How would I do that? Because I have got number of observations which are just representing the seasonality and the irregular trend, right? Now I use a small technique, right? Basically to identify or to cull out only seasonality from that SI, right? How would I do it? Let's look at in the next slides. Before we move on, moving average should contain this. Whenever you take a moving average of a certain order, that order should contain the seasonal period, or it should be equal to the seasonal period. Say for instance, I've got many, say 10 years of data, and the data provided to me is at a quarterly basis. Let's assume that, I've gotten different quarters. So what happens there is that, every quarter will have around 4 months in it. So I will have 4 data points in 1 year. And if I take a 4 order moving range, I will have one representative value for a particular year, which takes the average of all the 4 quarters, right? That's the technique of using or deriving on the moving average order. Say if you have got monthly data, right, and you have many years of data, the seasonality component could be 12-month moving average, right? Because in a 12-month moving average, if I take the average of the first 12 months, I will have one representative number which represents that particular year, and so on and so forth. So keep in mind, whenever you are deciding upon the moving average order, like if it's a 4-month moving average, 4-quarter moving average, 12-month moving average, whatever, it has to be equal to your seasonality period time, right? So that's typically something what you need to keep in mind before deciding upon your moving average order. So taking from where we left in the last slide, I've got an SI component now with me, and I've got quarterly data. And now it is time for me to extract just the seasonal component from that SI number. How would I do that, right? As I told you, I've got many 4 years of data, and I've got quarterly data. So I've got 4 data points per year, right? So every quarter represents a season, right? A season could be like a winter season, summer season, spring, and a fall. So I've got 4 seasons in it. So to make it easy, like if I can group the entire SI numbers, the seasonal component and the irregular component under each season, like I will put all the winter seasons for all the 4 years wherever the data is available. You see that this first point is missing. It's because we have taken the moving average. So when you take the moving average, there is a possibility that you can lose a few data points, especially on the top and in the bottom. And in this case, we have lost this data point of winter for 1998. We don't have that. but I've got 3 data points which corresponds to winter in these 3 years. Okay. Likewise, I segregate all the SI components under summer in this column in the running way, and for spring I summarize all these numbers 93, 90, 91, and then finally for fall, right, I will summarize this, right. So this is the technical way of getting all the SI under each season. And if I take an average of all these SI numbers, right, all these SI numbers, and the average will give me a smooth number which would have already removed the irregular component, because from a seasonal and irregular component is something which will swing out a lot. So if I take an average of those numbers, I'll get a point estimate which nulls out the irregular component, which leaves us with only the seasonal part. So for winter, the seasonal index is 110 percentage. This is all in percentage, and I'll explain to you how we reached in percentage. And for summer it's 97%, and for spring it's 91%, and for fall is 101%. So technically, when I put all my seasonalities together for a particular year, right, since it's in percentage terms, it should add up to 400, right. Technically, all of these things, if I add up, it should add up to 400. But unfortunately, we have lost a few data points here and there. This may be slightly more than 400. So in this case, it is around 400.8%. But to make your analysis very accurate, we will normalize this into 400. How would you do that? You just multiply this 110 multiplied by 400 divided by this sum, right? That's going to take the entire 4 numbers to the base of 400, and this is the normalized number. So if you add up these numbers, you will get exactly 400, and this turns out to be the percentage seasonal index for every season. So I've got 4 seasons in a year, which repeats its trend by itself. So I've got 4 seasons, and those for the 4 seasons, these are the SI percentages, right? Now that we have identified the seasonal component, the next task is to separate out the trend component from the moving time series, right? So if you remember, in my previous video, I have spoken to you about trend analysis. From a time series, if you do a trend analysis, we'll be able to extract only the trend component. So you can watch my video there to understand how we extract the trend from the moving series, time series. And trend analysis is one technique which we can use. We can also use moving averages, as we just discussed. When you take moving averages, it smooths out the irregular patterns, and then you will be able to only figure out what is the trend and the cyclical component, so on and so forth. So that is another technique what you can use, moving average technique, to smoothen out the data and just get the trend line. So with that, we are estimating T as well, right? So far we have estimated S, we have isolated that component, and now we've got the T component as well, right? Now the next task is to identify what is our cyclical component, right? So we have trend component with me now, right? By doing this analysis, I'll get my trend component. The next job is how do I get my trend alone? How can I isolate my trend? So if you remember, in the first slide, we did discuss that, if I take a moving average, the resultant will be T and C, right? Now, in this case, I have already calculated what is my trend. So if I divide my moving average with this trend component, the T and T gets cancelled, and what is resulting will be the C component, which is the cyclical component, right? In this case, or many of the cases, this component is going to be very low, close to around 1. So what you can do is, there are two options to you. One is that you can go through a very hard process to create a forecast for it, or you can just live with a simple assumption that since it's very low and close to 1, I will just treat that the forecast for cyclical term is always 1, right? That's a good approximation what you can do. So if you can approximate that, then you have got all the 3 things required to complete the puzzle for you. Right now, you have, from this method, you have identified what is your S, and using the trend analysis or moving average, you can separate out your T, and then finally, just by dividing the TC component, which is the moving average component, divided by the trend what you have identified from through this step, you can get the trend component isolated. Now, since we have already taken an assumption that this model is a multiplicative model, all you need to do is just multiply these 3 things together, because in the beginning itself, we assume that the model is T into C into S into I. So if I multiply these 3 things together, I'm going to get the forecast value for the required period, right? And all I'm leaving aside is the irregular component, which unfortunately none of us would be in a position to forecast, and that's the amount of error what we will live with. So if you are able to account for maximum regular components, and those maximum regular components, if that falls within TC and S, we are on the safe side. Maybe a very little percentage of error is something what we will have to live with when we use that particular model, right? So what next? So I just spoke about, just multiply TC and S and you will get your final forecast. So let me summarize the entire thing in, say, 7 steps. This is how you need to technically carry out your moving average ratio to moving average forecasting method. So first is to calculate the moving average, right? Calculate the moving average, center the moving average to isolate TC, right? First decide on the moving average order, then calculate the moving average, then center the moving average. When you center the moving average, you will get a component called as TC, right? And divide the original series by that MA, which is nothing but TC, right? TCSI divided by TC will isolate the seasonal and irregular component for you. Now that when you have reached the 3rd step, you have got the TC component and you have got the SI component, right? Next task is to segregate or separate out seasonality from here. How do you do that? Isolate SI by taking the average of every seasons, right? Average of the seasonality index of every season. If you take it, you will get the seasonality index percentage for a particular season, and that can be used for forecasting because the seasons are 4 different seasons in the quarterly data. You will apply those 4 continuously over time till the point you need the forecast. You can apply the same thing, right? The 5th step is to identify the trend or estimate the trend or isolate trend from this. For that, we will divide our moving average, which is nothing but TC, divided by the trend component, what we may have identified through trend analysis or moving average, right? So once you divide that, you will have your trend component and your C component identified, right? So obviously step number 5 you would be doing by using trend analysis, and step number 6 is just dividing your moving average divided by your trend component, right? That gives you the component C, and calculate the final forecast in the last step by whatever multiplication. If it's a multiplying model, just multiply TC and S and come up with the forecast required for the period. So this is how we generally conduct the ratio to moving forecasting technique. So to give you more clarity, let me show you an example and let me teach you how we do this in an Excel sheet. Very simple, right? Keep all these 7 steps in mind, apply these 7 steps, you will get your final results. And let's see how we do it in an Excel. Okay, so now let me open the Excel sheet for you. Okay, so we have the Excel sheet here, and this is the analysis what we are going to discuss today. Let me explain to you first the columns present in this Excel sheet. One is the timestamp. Here you get to see it's the timestamp. I have just used indicators here just to show the amount of data we have. So we have got 16 data points here. And here, before we could start, I told that, these are quarterly information available. So we have data right starting from 1998 winter, then through 2001 fall, right? So every year we'll have 4 data points. Those are 4 quarters, as I told, right? And this example is all about sales of a particular product in thousands. So 170,000 is the sale what we had seen in 1998 winter, and 148, 141, so on and so forth. So we've got 16 quarters of data which covers around 4 years, and 16 data points we have technically. So if you remember, the first step was to calculate or decide upon the moving average order, right? Since it's a quarterly data and we have got many years of data, we take moving average for, right? Because we assume that there are seasons within this, and various seasonality for a particular year can be seen in the 4 quarters, right? In the 4 quarters, how it behaves, that's the same way it's going to repeat in the next year as well. So if I take a 4 quarter moving average, I will be able to cancel out my seasonal component and the irregular component, because it repeats by itself in a quarterly way, right? In a 4 quarter way. So one period of seasonality right, will become 4 quarters. So in 4 quarters it will show one pattern, and that gets repeated, right? So I've decided on the moving average order, that's 4, and now I will go ahead and start calculating the moving average using 4 orders. So first 4 numbers I take and I calculated the average, it's 152, right? Here there is a catch, right? I have lost 2 data points in the 4Q moving range. Why? Because as I told you, this number is going to be a representative of the entire year 1998. But since we have taken 4 as the moving average order, there is no center point, right? The center point is 2.5. That is between spring and summer, right? I really don't have an observation. So where will I fit this number in this Excel sheet? That's the confusion, right? So in order to get a proper place for this observation, we need to center the moving average. How do we center that? So if I take the first 4 observation, the center value will become 2.5, right? 2.5 will be the location. If I take the next 4, the center value will become 3.5, right? So for the first set of observation, 2.5 is the center value, and the second moving average, what we have taken with 4, it's 3.5. So if I take an average of 2.5 and 3.5, the resultant is 3, right? So if I take an average of these 2 things, I can comfortably fit in that value, which I get as an average, against the third observation, right? That's how I have centered this. So this is called as a centered moving average. So once I've calculated, this column is all about the moving average. So what is moving average? When we took the moving average, we cancelled the seasonality, we averaged out the seasonality, and we averaged out the irregular components in a period of 4 quarters, right? And left out is only TC, right? From TCSI, I took a moving average, I cancelled SI, and this component is all about TC, right? So the next step is to identify SI from this. How would I account for SI from this time series? I want to isolate the SI. So how would I do it? So TCSI is my original series, right? And I've got moving average already identified. So if I divide TCSI by TC and TC gets cancelled, and I will get an SI component, right? So for ease of understanding, right, to understand it much better, I would want to represent this SI or seasonality and irregular components, that component in terms of percentage. So what I do is that I divide 141 divided by 151 multiply by 100. So this becomes the ratio to moving average, right? This is a ratio to moving average which is expressed in terms of percentages. So I've got 93%, 100%, 110%, 93%, so on and so forth, right? These are nothing but my SI component, right? The SI component. So I've got TC component and SI component with me. So with this, I have completed my step number 3, right? I have identified the SI. So the next step in front of you is to basically segregate or extract only the seasonal part from this SI component. So how would I do it? Because now I've got all the seasonal percentage moving range of SI. I can just segregate these readings as per different seasons of a particular year, right? So 93 corresponds to the spring of 1998. So if I have to put all the springs together, how will I do it? I will collect these values, right? I will collect these values together. Right? So let me color code it for you all to understand it better. So I will have to put all these values together, right? I'll take the spring 1999, spring 99. Exactly. So all the springs are together now. So I take all these values together: 93, 93.83, 100.69, and 97. So the average of this is 96.42 will become just the seasonal component, because in this component, the only irregular component, the variation, will be of only the irregular part, right? So if I take an average of these numbers in all the seasons, that will smooth out the irregular component for me, which leaves out only the S component. So how would you do it in a very systematic way? We can create a table like this, right, where you put all the years, and then you have the seasons here, and then group it according to the seasons from this column, right? So what happens is that, all these things, as I told you, is the percentage ratio to moving average. You are expressing this in terms of percentage. So you always need to keep in mind you have multiplied something with 100. So when you're using this, you have to divide that with 100 to get the, so this is for ease of representation, right? So if I take the average of these every seasons, this number is basically only seasonal. So this is the seasonal index for winter, for summer, for spring and fall. So when I say winter, it's 4 months, summer 4 months, spring 4 months, and fall 4 months. So these are the seasonal indexes. But what happens is that, when you add this up, ideally it should be summing up to 400%. But here, there is something little over 400 because of the missing values what we have had in this, right? So what we do is to normalize this to 400. What we do is that, we just multiply this number with 400 and divide it with 400. And so you're basically getting all these numbers to the tune of 400, right? So once you have that, when you add this up, you will get to see that, your seasonal indices also ties up to 400 now. So this will become your seasonal indices, and you will start applying this in the next column, right? You see this? These are the 4 seasonal indexes, right? And it repeats by itself, and you have a seasonal index corresponding to every single data point you have in this time series. Okay, so now we have completed the 5th step as well, where you've isolated the S factor, right? The seasonal index you have isolated from the total time series. And now you can very well, if you want to look at, okay, I want to look at the time series eliminating the seasonality from TCSI, you just need to divide TCSI should be divided by column S. So S gets cancelled, and what you will get is TCI will be a series without seasonalities. It's called as deseasonalized data. Okay. So next step, what you have is to identify or to extract trend from the entire data points, right? So how would you do it? We can use a simple linear regression, thinking that it is a linear relationship. We can use a simple linear regression. How would you do that? First, we need to identify the intercept and slope of the TC, the component TC. Where is the component TC here? This is a component TC, right? Yes, these are the components of TC, and are the corresponding timestamp values, right? If I use the formula intercept is equal to intercept and is equal to slope for these two corresponding values, I will get my slope and intercept. So let's see how I have applied it here. So is equal to intercept of x and y. This is my y and this is my x. So that's going to get me the intercept. It's 152, and slope, again the same formula, is equal to slope of my y upon x. So that gave me the intercept and slope, and by just substituting this in the equation, we get the trend component coming out. So how would you substitute this? This is b0 and this is b1. So zt is equal to b0 plus beta 1, right, b1 into the t of a particular timestamp, right, is equal to the trend, is equal to z, right? Zt is equal to beta 1 plus beta 0 plus beta 1 into t. So I'm applying that formula here to get the trend, right? So what is my beta 0? Beta 0 becomes 152, and plus beta 1, which is the slope element, is minus 8374 multiplied by the first time element, which is timestamp number 1. So that's going to give me this forecast of 151. I just need to drag the formula down, so I will get the individual trend component from this time series. This I have done using the simple linear regression technique. So by completing this step in column I and column G, you have got two basic things what you were really looking at, right? You have the S component, which is the seasonal index, and now you have got trend components. Finally, one thing is remaining, which is the cyclical component. So as I told you, if I have my trend component already with me, I have the moving average, right? The moving average, which is the TC. So if I divide this with my trend component, that's going to leave out what for me? That's going to leave out the cyclical component for me, right? So if I divide my, so again, some of the parts will be lost here because as you know, it is technically we have lost some of the components because of the moving average effect. So you see that here almost all the cycle is close to around 1, right? So we've identified that the cyclical component is too small and it is actually closer to 1. So instead of sitting and doing a very difficult task of forecasting these numbers beyond 16, we can very well assume that since it's very small and it is consistently hovering around 1, we will go with an assumption that approximately it is equal to 1. So you can assume that your cyclical component is small, approximately equal to 1. So if you are okay with that assumption, then you have got the S component already identified and the T component already identified and the C component, right? You have got all the beautiful 3 components for the time series except the irregular component, which we feel that we will live with that amount of error or that amount of risk. So now how will I calculate my final forecast, right? So my forecast is nothing but a product of T, C and S. Keep in mind this seasonal index what we are taking, right, is a percentage. So we need to bring that percentage down to the real seasonal index. So how would I do that? Just divide it by 100. So I've got I6 multiplied by seasonal index divided by 100 because I am expressing this in terms of percentages. I want to bring it back to the original terms. So I just divide that with 100 and then multiply that with K6 here. See? So my product, this is a multiplicative model. So if I multiply this, I'm going to get the forecast, right? So till 16, I've got readings. right? Till 16 at this point I have got reading. So whatever after this is technically the forecast I have generated for my moving average method, right? So this is a way in which I would calculate the forecast, and this is an example, and this is very well, this is an easy example, right? I mean, this is an easy example, and it's very easy to do it in Excel sheet as well, and this is very, very straightforward. So if I have to take the same examples and go to Minitab, right? In Minitab we have a pre-fed option to do this. Although the results may slightly differ because of the assumptions what Minitab makes and we make, it's a software, right? So it has a lot of assumptions taken. So it may not be grossly different, but there will be slight deviation. But let me show you how we do this exercise in Minitab, right? So I hope that let's go to Minitab and let me show you. Let me open the screen Minitab for you. Right, yeah, I've got it here. Okay, so in here we will see that you've got the quarter data and I've got the sales data here, right? So all I need to do is that I just need to copy paste this data like the way I do it in Excel, right? Ensure that you write the column headers right properly, and then copy paste right starting from column I. All you just need to do is just come here, click it, Control C, and then come here and paste it. So the job is done. So maybe I can paste it again. That's it. So it is completed, right? So I don't want to do that again. So it's completed. So it's done. Now let's go to statistics. Time series you have, and then you have got the decomposition method, right? Where I will select the variable as sales in K, and the seasonal length, as I told you, it is 4, right? And it's a multiplicative model, and I have got trends plus seasonality, right? And what I want to generate is a forecast from 3, and the starting where I should start the forecast from is from 16. So 17, 18, and 19 is something what I need, right? And I can just go to storage. If you want to see any of these data points in the Excel sheet, it has to be stored. You can ask for it. So if you want to get the deseasonalized number, seasonally adjusted number, you have got the detrended and you've got the trend line, right? All of these things you can ask for. If you want to see that on this sheet itself, it will feed for you, it will store for you, and the results, okay, summary table will be there available for you, and graphs, individual plots, all 4 in 1, I would call it as residual plots 4 in 1, and that's it, and I'm good to go. If I click on OK, that's going to throw out the results for this model, right? So you will get to see a lot of graphs popping up. This is a very interesting graph. First thing what we need to look at, the actual value is the blue line, what you can see here. This is the actual time series, and these are the forecasts, right? What we generated using our multiplicative model, and these are the forecasts we just generated, the 3 more forecasts. And look at the MAPI, right? I mean, I would always suggest go with mean absolute percentage error. So this error is in terms of percentages. So 2.5% is the error, which to me looks like pretty much okay, that I can rely on these forecasts, right? So this model looks to be okay for me, right? I will probably want to increase it further, but for now, for this example, I'll just say that okay, this is good enough for me. MAPI error. You can also look at MAD and MSD. It's mean absolute deviation. So these are absolute deviations. So it's an absolute number. You will calculate the deviations, and then absolute deviations, that means the difference between the fit and the original value, and then take the mean of it. So the deviation is about 3.69. It's still okay. We are dealing with hundreds of sales, so I'm on an average deviating by 3.6. Mean squared deviation. So if you're not going with the absolute numbers, what you would do is that you will have negatives and positives there, right? We've discussed on my standard deviation. So you square it and then take the average. So that's about 23. So this is more from a statistical perspective. I would recommend either go with MAP, which is my favorite, or MAD, which gives you a good understanding in terms of how much of a deviation this model, or this model what you have built in is having, right? Or the amount of accuracy you can expect from this. Okay, so that's all about it. And then, you know, if you want to have a look at the other components, decomposition components, you know, this is the original data, this is the detrended data, this is the seasonally adjusted data. That means, you know, the seasonality has been removed from this data. All you will have is TCI, right? And this is the only component, CSI data, that it is, the trend is removed from it. And this is seasonally adjusted and detrended data. So if I have to move seasonality and trend from it and then look at the data, this is how it is going to look at. So this gives you a lot of indication. So this is the normality plot of residuals, right? So the assumption is that, you know, the residuals in regression, you know, it should be normally distributed. So we are not getting into that we have already discussed. So these are the seasonal indices, right? You know, I've got four seasonal indices: winter, summer, spring and fall, and these are the indices, and this is how the variation of the indices happens. And percentage variation by season, right? You know, there's a 15% variation in the season 2. There is around 23% variation. And the detrended data by season, right? You know, once you detrend the data, how the data box plots look like, and the residuals by season. So all of these things will generally give you an awareness in terms of what's the variation levels for the multiplicative model what you've used. And most important information will come in the session window. We can always come here and click. The session window will open up for you. And let's look at what is the session window got to give us. So data is sales data. As I told you, length is around 16 data points. We have got 4 quarters each, 4 years. And this is the trend equation which we have used, the regression equation which we have used to calculate the trend component. And seasonal indices, if you remember, you know, we've gotten percentage in Minitab, it is in the absolute numbers. When we multiplied with this number is when we got the percentages. So we have got the 4 quarters, you know, 4 seasons and 4 quarters, right? You know, the winter, the summer, spring, and the fall seasonal indices, and the MAPI error, right? 2.5% of error. And here you can see that, you know, you can see the forecast for 17, 18, and 19, 153, 135, and 124 is the forecast, and the error and the accuracy measure is about 2.5% error, which is close to around 97%, 97.4%, which is okay for me to live with. And this is how I generally do a decomposition model in Minitab. So now that we have covered both Excel and Minitab, and I hope you could understand how we do it. But still, if you have got any questions, please feel free to drop a mail at info@trainfirm.com. I will try and explain to you your or resolve your queries. And if you still further need any supports, drop a mail so that I can set up a WebEx session with you. We can get one-on-one, and I'll try and help you out to solve your problems. And you can expect a similar video very soon, which will just talk about how to handle ratio to moving average forecasting using our software, right? It is a new software what we generally use in the analytics world. And I started off with statistics, and I started off with the simple tools, how we can do it so that you understand the fundamentals. R is going to make it really easier for you. The codes are available. You just need to apply the codes and get the numbers out. So I will teach you that as well, so that, you know, you are getting prepared to the new AI and ML world, where, you know, if you want to change your domain from your existing domain to analytics, those are the skill sets what you really need to have. Of course, statistics is the base of it. You know, without statistics, if you know the software, you are not going to get anywhere, right? So first you will learn the statistics, then you will learn the simple tools, and then you get to R, so that you have a complete package to be ready to take up any analytical roles or analytics profession, right? Thank you so much for watching this video. Just feel free to contact us if you have any questions. And I repeat, it is info@trainfirm.com. I hope you enjoyed the video. Thank you so much for watching, and I'll talk to you all soon. Bye for now.